So to look at limits of sequences, we look at the limit as n approaches infinity of the a sub n term. If that equals L, where L is a real number, then the series is said to converge to L. But if the limit as n approaches infinity of the a sub nth term does not equal L, where L is a real number, then the series is said to diverge. Determining what value that the series with the nth term converges to, or we will state whether it diverges. So if that nth term goes to a number or goes to infinity. Then we'll also check graphically. So our first example, we have a sub n is equal to 2n over n plus 3. Looking at the limit as n approaches infinity of a sub n. So looking at the limit as n approaches infinity of 2n over n plus 3. Substituting infinity, we get infinity over infinity. So I'll have to use L'Hopital's rule. So by L'Hopital, we have the limit as n approaches infinity, deriving 2n to get 2, deriving n plus 3 to get 1. So substituting in infinity, we get the answer of 2. So that means that the series will converge to the value of 2. So the a sub nth term as n goes to infinity will approach the value of 2. Next example, we'll look at the a sub nth term is equal to n over n squared plus 1. So the limit as n approaches infinity of that a sub nth term, so n over n squared plus 1. Substituting in infinity, get infinity over infinity. So we'll have to use L'Hopital's rule. We have the limit as n approaches infinity, deriving the n is 1. Deriving n squared plus 1 is 2n. Substituting in the value of infinity, we have 1 over infinity, and 1 divided by a very large number becomes 0. So the series then will converge to 0. So the a sub n term as n approaches infinity will go to 0. The next example, we have a sub n is equal to negative 1 to the nth times the quantity of n plus 1 over n squared plus 2. We have the limit as n approaches infinity of negative 1 to the n times n plus 1 over n squared plus 2. We have to look at this in two scenarios. We have the limit as n approaches infinity if we use an odd number would be negative 1 times n plus 1 n squared plus 2. So the limit as n approaches infinity of negative n minus 1 over n squared plus 2. And then by L'Hopital's rule, limit as n approaches infinity, we'll have negative 1 up top and 2n in the denominator, which then that approaches 0 from the negative side. Then we'll also look at the limit as n approaches infinity using n as an even number, which will make a positive 1 times n plus 1 over n squared plus 2. So we have the limit as n approaches infinity of n plus 1 over n squared plus 2. And by L'Hopital's, we have the limit as n approaches infinity of 1 over 2n, which also approaches 0, but then from the right side. Since those two values are equal to each other, the series will converge to 0.